Thank you, and good morning or good afternoon, everyone, wherever you're at. Welcome to Mazer Consulting's webinar, where today we will discuss vertical or high-rise construction, presented by myself, Jose Morales, a surveyor, and Michael Cardo, which will hop on here in a little bit, also a surveyor. We are out of the Mazer's Miami office, and we specialize in high-rise construction surveying. Such as the example in this picture here is Residences by Armani, which is in Sunny Isles, a project that we worked on for probably 2 to 3 years on a typical project like this size. Vertical construction or high-rise, for the purpose of this discussion, high-rise, we loosely define it pretty much anything that is over 20 stories tall. So anything smaller obviously would be a mid-rise or low-rise, even lower to level. But for this particular topic today, we will discuss high-rises. Just kind of do a little introduction. With, like as I mentioned, we are from the Miami office. I found this this map from the Miami Downtown Development Authority. And it displays just in the downtown area, sort of what the development pipeline looks like in Miami, Florida, downtown Miami, Florida. Those buildings represented in green are planned buildings. Those in magenta are proposed. The cyan buildings are recently completed, and the blue are under construction. And this data is as of a couple of days ago. So I want to say it was 2 days ago. So the 18th of August. So to kind of give some values to these, to that previous map that we had up, of those pipeline developments, 117 of those are currently being proposed. 13 are actually planned, 28 are under construction, and 74 have been recently completed. So what we see here is, and even in this particular slide, you see there, I just picked out 12 random projects. Of those 12, there is 9 that are high rises. One doesn't have a picture. One seems to be just a low rise 2-story building, and the other one seems to be a mid rise. So there definitely is, no pun intended, a rise in these high rise construction in these highly congested areas where property value is obviously at a premium. So the only one way to build, and that's up. And of course, this is only the city of Miami. This excludes the Miami Beach, the Miami's beaches, the island to the east, which is about 13 miles of beach, and that extending from South Beach all the way up to Sunny Isles, which is the northernmost part of the county, and then obviously extending further north to Fort Lauderdale and its beaches. So there's definitely a trend where the construction in certain areas is going up, vertically speaking, construction, not to mention just the amount of it as well. So for the most part, when we do a quote unquote high rise, we follow kind of a general workflow. We start obviously with some preliminary work. Then we follow it up with some control work, horizontal and vertical. Then we can actually get into some actual construction and construction layout type task. And then we can finalize the project with, depending what the closeout document requirements are for the contract and the general contractor, between the general contractor and its owner. And then additional scopes are just anything that's not originally scoped that they, as we're going through the project or trying to close out the project, they realize they have to do to close out their permits. So we start with number one being the preliminary work. If you can categorize the preliminary work as being the first part, it really entails doing a property, what we call a property boundary analysis, and the plans analysis. So what is the property survey analysis? The goal here is to basically reestablish the boundary so that we can relate the existing boundary, which was not, it will not change throughout the project, with any with the building and any other proposed improvements that pertain to the building. And in this phase, it's just like the regular surveying of a boundary. You run your traverse and you locate property corners. Redundant measurements are critical because this is your survey controlled, much like any other boundary survey you would do, except that way you have the intent of actually aiding in the construction process as it goes into the next phase. Once we have a good boundary, placing the building and verifying the setbacks is probably the next key step. In this particular example, this is a downtown project. It was not a big building, but what's a concern here is that is in the downtown area. So there's buildings really adjacent to the property lines, which make it always difficult to, bring control up. And it just makes it a little tighter spot to work in. The plan analysis portion of it is basically where we compare, obviously, for our survey layout that we need to do from the contract with our client. We compare all the architectural, all the structural, all the civil plans to make sure that there's no conflicting information from one sheet to the other that affects our survey layout and scope that we are working primarily with. Obviously, any discrepancy that affects our layout is communicated immediately with the client. At this point, this is more likely that we're going to write 1 or 2 RFIs to the client, RFI being a request for more information or some sort of clarification. If you have a question on the plan or you just don't seem to find a dimension to get a specific size and location for something that you are involved on from a survey perspective. At this point also, it's kind of the time where you should involve we normally have an assistant PM, a surveyor, to aid in the quality control. It's important to, that I don't just start putting out RFIs for questions that not necessarily are needed or it's in another sheet. So having that second person overlook or review your information can sometimes, avoid having to send a client a question when it's on a separate sheet or on a detail, and can avoid that. In this particular RFI, it's just a simple one. It's a typical example of where there's a discrepancy in dimensions between the grid lines, and that's something that's critical that you want to sort and get corrected at the beginning of the project before we do any layout, considering that is one of the key things we do with construction is the grid lines. And I will turn it over here to Mike. He's going to continue and I will follow up.
Thank you, Jose. I want to thank everyone for showing interest in our presentation and what we do here at Baser. I'm Michael Cardo, Survey Project Manager at our Miami office. I'm going to be talking about control now. Control is the most important thing in the job site because everything that gets built and installed will be based on the control. The control consists of a network of permanent points physically set and identified underground around the project site. Depending on the surface material or the conditions, we'll choose a magnetic nail, a pin, a hub, a scribe, or any other mark that we have available. These points are assigned coordinates at elevations. Also, physical points referencing this main control will be set away from the area of disturbance as to be able to recover any of these points if they get destroyed or disturbed in any way. On the sketch on the screen, you'll see the blue lines showing the grid line control offset lines. You'll see benchmarks. There's one on the bottom left of the screen, TP21. There are also points identified as McNeil washer. They have a point number on the elevation and the datum, the vertical reference elevation. Next slide. A traverse. Everything starts with a traverse. All these points, once we choose the location of the points, we will, using our high precision equipment, will run measure redundant angles and distances through them. A traverse is typically an irregular closed geometric figure defined by physical marks at every angle, as shown here in the sketch. Setting control is typically done during our first field visit. Everything gets located from this control, including the property corners. Marks are often disturbed or destroyed due to heavy machinery, construction traffic. Their view can be obstructed by parked equipment, storage materials being stored in between them. So we have to constantly be recovering points, and the reference marks are really, really good help for that. Next slide. Once we run the traverse, we have assigned horizontal coordinates. Now this is a stage. Vertical control is ren. Elevations are ren, and these points are assigned with elevations. So typically what we do is we research vertical reference marks on the public online databases such as NGS. In the case of the area here, Miami-Dade County has a database online. City of Miami have maps, and City of Miami Beach have maps as well. So we'll be able to find the nearby benchmarks. Typically, we choose 2 of them. We start our measurements at 1 benchmark. We run through the site, setting benchmarks around the site, and then we close on a 2nd benchmark. The datum that we choose depends on the plans. So most commonly used in South Florida are NAVD 88, NGVD 29, City of Miami, and City of Miami Beach datums. The elevations are published on our control marks and survey sheets. Some of the survey sketches required by the municipality are required in a specific datum. So when we choose the datum based on plans, we'll have those elevations posted on the control points, and when we submit these surveys to the city, then we'll have to convert the values to show what they want to see on their survey sketches. High accuracy equipment such as digital levels and 3-wire levels are used to transfer these elevations to guarantee solid values on these points. Again, they're going to be used to build a giant structure, and they need to be solid. We verify elevations on the existing or design elements shown on the original survey, which is usually commissioned by the owner, and utilized for design to ensure integrity of the data. So we'll measure features that we know have published values on the plans, and then we'll verify and check that they are consistent. Next slide. This is the site control plan and coordination sheet. This is the reference sheet for control. Prior to construction, the contractor would choose offsets to architectural grid lines. These marks will be set at ground level in the field during the construction layout stage. We refer to these grid line control offsets as control lines. And they're shown, in this case, they're shown as yellow, blue. Sketch is kind of not readable, but they're there. The offset distance from the grid line is chosen based on the ability to physically mark the lines with minimal obstructions on the slabs. Obstructions can present themselves as structural elements such as walls, columns, elevator shafts, and we need to minimize the obstructions so the contractor can mark a line across a hallway, for instance, with minimal chances of running into a column or wall. The control sheet shows control points, control traverse angles and distances, horizontal coordinates with elevations, the descriptions on the marks, whether it's a magnail washer, whether it's a scribe mark, a pin. Typically, we prefer to set magnail washers on concrete. The control lines are also shown on the sketch. We also show dimensions from established plan, based on the plan analysis. We'll show dimensions from the boundary to the building and the grid system. So there's no question as to where the building is placed with respect to the control. Next slide. The next stage is a construction layout stage. This is where we start marking commodities on the ground. We usually start with a pile layout, which you have a sketch here on the right. The sketch on the right is a pile numbering sheet. It shows the pile locations, their unique number designation, the architectural grid line system, and some structural foundation elements such as grade beams and pile caps. The contractor will want the building corners marked, usually. They will typically request setting marks along the boundary lines for the purpose of installing silt fences, construction fences, clearing vegetation, or simply for visual aid. We'll also review utility plans and mark their center lines for trenching. Typically, a water main, sanitary sewer, storm drainage, and FPL are the most common requests. Will typically be requested to capture the location of and the elevations of these FPL conduits and storm pipes and structures for the purpose of preparing as-built survey sketches for record later. Slide 15. Next slide. This picture shows a sample of a building layout plan survey. We typically mark the corners of the building, and we set at least 2 reference marks per corner, so that in the scenario or the case where one of those corners is lost, they can recover it without needing us to come back out there. Marks get run over by construction equipment all the time, vehicles and workers. It happens often where marks are destroyed and they need to be recovered. So offsets help a lot. Next slide. This slide shows a elevator shaft, the form on the left with a rebar. It shows the finished first 3 levels of the shaft on the right. We're typically retained to lay out the corners of the elevator shaft. Again, we set the corners and then we set reference marks to the corners just in case they get lost. They'll have reference marks to recover them or to reestablish them. Next slide. CloseUp documents. So CloseUp documents are typically requested during later stages and end of construction. Submission of all signed and sealed surveys is required. Samples of documents that are part of the CloseUp documents are pile as-built sketches showing the deviations of every pile that was installed. Drainage well as-built showing the latitude, longitude, and elevation of the installed well structure. Public Works will require a final as-built survey showing all finished improvements, elevations on the sidewalks, new utilities, and the building itself. FPL easement documents, so we'll, like I said before, we'll as-build the conduit that was installed. We'll capture the horizontal location and the elevation, and then we'll publish it and draft an easement, a legal document giving access to the power company to maintain their equipment if anything shall be maintained or replaced. As-built surveys on slabs showing finished elevations on the slabs are also part of the CloseUp documents. Final settlement report showing the final building settlement. The Federal Aviation Administration survey showing the building height is also part of CloseUp documents, and there's a couple more. But these are just the most typical examples of CloseUp documents. Next slide, please. Here you have a sample of a drainage well as-built. On the left, Public Works right-of-way survey, which pretty much looks like a topographic survey. In the middle, and then a sample of an FPL easement, one of the sheets anyway. The easements usually consist of a few sheets. This is just the one that shows the graphical location of the the easement and the center line of the conduit. Next slide, please. Vertical as-builts. So the sketch you're looking at here shows slab elevations at level 46. I believe this is Paramount, one of our projects. The elevations are measured at predetermined locations on the survey floor, or whatever was agreed upon in the contract. This is typically done for to report to the engineer what the elevations are on those spots. On the case of tensioning slabs that have tensioning cables, we typically do 3 of these. One before they pour the concrete, one time after they pour, and a third time after they tension the cables. Elevations change because of the stressing. So, we submit the documents to the engineer, and they analyze the data. Everything, again, sketches are typically produced within 1 working day of the field survey for the engineer to review the data. Everything in construction is required yesterday, so that, we try to do this as fast as possible, quick turnarounds. Next slide, please. The settlement report. So the contractor will choose the columns where the monitoring pins will be set. We'll go around and set tap guns usually on the columns. We identify them with orange paint, and we write the designation, a number or a letter and a number. We'll measure the initial values with a high precision digital level or 3-wire auto level. And we'll begin a report, as you can see on the samples I have on the right. The top one is the layout for the marks, and the right is a report measured in different dates. This, I think, took about 1.5 years, and the building, I think, settled a few inches. So we'll continue measuring these pins as the building gets to the higher levels. Usually we propose every 5 levels. And another time when the building reaches the top, after the top out. Next slide, please. This is a sample of an FAA survey. I spoke about it before, Federal Aviation Administration. Federal law requires that the Federal Aviation Administration determine whether a structure that is proposed to be built 200 feet above ground level or higher or near an airport does not propose a hazard to the airspace. This survey is required to show the pre-construction and post-construction building heights. Obviously, when they propose the height, settlement may not go as predicted, and it'll maybe settle more. So the heights are going to be different, pre-construction and post-construction. In the case of this sketch shows 1000 Museum. The highest point was a helipad on the roof, and we were required to publish the latitude, longitude of the corners of the helipad and the elevation on the helipad. Over to you, Jose. Thank you guys for your attention.
Thank you, Michael. Which brings us up to the additional scope items. We have a little package that we prepared on a typical construction site, but obviously every construction of a high rise is not going to be the same. The conditions aren't going to be the same. So obviously there's always going to be additional scope items, and depending on the contractor and their obligations to the owner and their contract, they may need additional items. But the typical, a couple of additional scope items that we haven't talked about, but I wanted to mention is the elevator shaft as built is critical, obviously, to any high rise. There's a picture of earlier Michael had shown of an elevator shaft layout, and what looks to be like a giant elevator shaft. That's one of our buildings we worked on at Dawson Museum. I think there was a total of 8 cars in that building alone, in that elevator shaft. So the elevator shaft being critical to not only the function of the building itself when it's completed, but when it's just a structure itself, a concrete structure, it needs to be plumbed with minimal errors in the concrete for the installation of the mechanical equipment in the cars themselves. Typically with these high rises, they're going in downtown areas where they're really close to adjacent buildings. So the adjacent owners of the buildings they want to protect their building as much as possible. So we do existing conditions report. We will document the conditions of the adjacent buildings prior to constructions commences by pictures, videos, reporting any sort of imperfections or cracks or defects on the building are documented, measured, and in some cases we actually just scan the perimeter of these buildings because that gives us a picture and a LiDAR point cloud to measure those defects, if anything. And just in case you miss it visually with your eyes, you can capture that and store it in a point cloud with images. And along the same lines, once the project is finished, in case there's any disputes, there's always a post conditions report to show that there was no damages done during the construction period. So that's one useful a task that we do. Obviously, with these buildings under the underground, I think Michael mentioned underground layout of utilities. These buildings, there's not much property, so everything is housed internally in the building. So sometimes laying out the trench work for these, and then the final documents that pertain to them for the respective departments to access the equipment. Another one is pre-pour form checks. Even though the grid on a building might not change from floor to floor, doesn't mean your slab is not going to change. These are beautiful architectural buildings that obviously being just a rectangular building is not going to suffice. So in some cases you have slabs that are different at every level. So they want to double check that where they're going to pour this slab is in the right place and according to the plans. To kind of wrap things up here, obviously I've mentioned each building is different. Each building is, has the architect stamp, so it's uniquely different. The property is different. The location is different. So it presents obviously unique opportunities for us to come up with new strategies to be efficient and expedite some of the work for the general contractor, our client. And of course, Maser tailors every services that it has depending on the client needs, and those client needs are obviously dependent on the owner's needs. A little bit of the actual process, the communication is always key, not only within our technicians from the project manager to the assistant project managers to the field crews, but also to the client, their PM and their superintendent and their assistant superintendent, so that we are kind of seamless in the background, but working on their schedule, so that as to not hinder that schedule. Usually these schedules for constructions are pretty tight, and obviously there's lots of money involved, so they want to build it as fast as possible, as safely as possible. Maser has been doing this kind of high-rise construction surveying for the last 20 years from the team built by Mr. John Liptak and Jeffrey Tuckban. So they have personally been shaping the skyline in South Florida for the last 20 years and continue to do so, and hopefully for 20 more years with some of the newer staff that they have taken on to train and help continue the reputation that we've built down in South Florida. To learn a little bit more on this webinar, or you have any questions, later on today, be sure to submit those to survey webinars at maserconsulting.com. Or if you're interested in any upcoming webinars, be sure to visit maserconsulting.com events/events, and they should have a list of future events that are coming up such that you'd be interested.
Thank you, Jose and Michael. We have a couple questions here from the participants. Well,
Oh, sorry.
can you hear me okay there? Okay, sure, no problem. The first question is from Jeff. Do you assist the contractor in getting the high mast cranes set up? And that could either go to Jose or Michael, whoever wants to answer that question.
I could answer that. Once we are done with the boundary analysis and we have our control, and I've double checked everything with whoever's helping me with the project, we can pretty much lay out anything on that site or building. And that's why it's so critical that we spend the extra time at the beginning of the project doing all our reconciling the boundary, placing of the building, and then making sure that any question or doubts that we have on the plans are answered, and we're can confidently go ahead with labeling anything. And that being a lot of it is the crane. The crane is the tower crane for any of these tall buildings, whether it be one or two or three. I think there's some pictures that we have where there's three are critical. They require their own foundation. And yes, we have laid them out the footers for the crane. And as a matter of fact, we actually check to make sure the crane is plumb as they're putting it up and erecting it.
Okay, thank you. And I know that the slide before you did mention that over the past 20 years, you have helped build the skyline in South Florida. So this question from Michelle asked, do you offer this type of surveying services in all of your locations or only in South Florida?
Mike, you want to answer that, or?
I'm sorry, I was reading Kevin's question. What was?
Okay, so this question comes from Michelle. She asked, do you offer this type of surveying services in all of your locations or only in South Florida?
We do. We South Florida is not the only office we have with skilled people in the field to work on these projects and professionals that will be able to handle high-rise construction.
Okay, great. And then, yes, Kevin asked the question here. He wanted to know if you could talk about the importance of working with the most current conform design drawings set for a project.
Extremely important. We, as surveyors, we're on the site early on in the stages of construction. We set the control. In the meantime, we have the architects and the structural engineers working on the foundation. Even at the point where we're required to lay out the piles for the foundation, they are modifying the design because of issues that arise. And it's very important for us to always have the latest plans. I don't mark anything in the field unless I am guaranteed to have the latest plans for whatever commodity I'm laying out. Even when the building is on the higher levels, they'll be working on the design and changing things. So anytime I'm being asked to lay out something in the field, I require them to send me the latest CAD file and PDF of whatever sheet shows what I'm laying out.
Great question. Thank you. And the one final question from Dan. Do all of your crews have the proper safety training to work on the high-rise buildings? And is there specialized equipment that they have to use?
You want to tackle this whole thing?
Yeah, of course, the most typical is fall protection. And for the most part, I can't say that we've ever had any situation where we go somewhere and the contractor has not taken the necessary steps to secure the area, whether it be 2x4s to block off from falling. But we obviously all our personnel are OSHA 10, OSHA 30, and I think some OSHA 40 trained to work in construction. Also, fall protection equipment, your lanyards, your yo-yos, as they're called, and we also have the 50-foot lanyards so that we can kind of almost freely walk around the deck, but still be tethered for fall protection. So yeah, we're trained. We do our health and safety, and plus most of these sites have an on-site safety officer that is constantly monitoring these things to make sure that it's safe for the workers to work.
Okay, thank you. That actually does conclude the Q&A session. So if you guys have any last little remarks or comments, Jose and Michael, for the participants?
No, I would just want to say thank you for joining us. The picture I have up there, by the way, we've said at 1000 Museum a couple of times. That's one of our signature buildings in South Florida. I was a renowned architect, and that's the building on the right side. It's downtown Miami. The one on the left is more a beach, Sunny Isles Beach. That's Jay's signature. All these pictures you see here are all pictures that we have been or are personally involved in construction and working on. Each one, like I said, is about 2 to 4 years that we work on them.
Thank you. Have a good one.